Hello students, welcome once again to relative velocity. Last time we saw that for relative velocity of parallel vectors, we assign positive sign to vectors moving towards east or north in our lesson 1. That is what we said. And if the velocities are parallel, the vectors are parallel, and they are moving due west or south, we assign negative sign to it. So now let's look at today what we are going to do. I want us to analyze several cases, okay? We are still on parallel vectors, okay? We are still on relative velocity, so I can write it here. Relative velocity of parallel vectors. Right, so we are looking at the first case. Look at this body. These two bodies are parallel. Body A and body B. Body A moving with velocity v1 and body B moving with velocity v2. For example, if I want to find the velocity of B relative to A, how do I find it? We know that by definition it is Vb plus negative Va, right? So this ends up giving us Vb minus Va. That is what I have done here, alright? And what are the velocities? According to the diagram, the velocity of B is v2 and the velocity of A is v1. That is why we have this equation. So take note of that. Good. Let us look at another case. Why did I do this? Let me go back and see something there. I did it because here they are moving due east. And if they are moving due east, it is positive. So nothing happens to the conventional sign. The only thing that changes is the formula. The minus here is already in the formula for VBA. Okay. Here we are using VBA. If I were to find VAB, that would have been VA plus minus VB. Okay. But that is not what we are. I want us to find VBA. Okay. So here you see that the signs didn't change. The signs are positives throughout. The negative sign we have here is for the formula. Good. Let us look at another case. This time VA is moving towards the west. These are also parallel vectors. B is moving towards the east. So how do we find it? We are looking for VBA. So if we are looking for VBA, then this becomes VBA plus the negative of what? VA, right? And this becomes VB minus VA. That is what we have here. So let's ask ourselves, what is the velocity of B? The velocity of B, because it's moving towards the east, is positive. So V2. But look at A. A is towards the west, so it will be negative. That is why I have negated the V1. So we negate it and we get this. And the negative gives us a positive sign. I hope you are following. Alright, let us look at another case. We have a case where VA is moving towards the east with velocity V1. B is stationary. This diagram means it's stationary, it's not moving. So if I want to find VBA, then what do I get? How do we find VBA? Sorry, how do I find VBA? VBA is going to give us VB plus minus VA as usual. And this ends up giving VA minus VB minus VA. But look at B. The velocity of B is stationary, so it's 0. So we get 0 here. Okay, minus, what is the velocity of A? The velocity of A is V1. So I put it here. And 0 minus V1 gives us negative V1. We are looking at these instances because we will be using numbers to solve examples on this. But here we are just using letters to illustrate something for you. Another case. This time, both of them are moving towards the west. They are parallel vectors. So if we are finding VBA, velocity of B relative to A is going to be VB plus minus VA as usual. So VB minus VA. But don't forget, because they are moving towards the west direction. Both of them are moving towards the west direction. So A is negated. What is the velocity of B? B is v1. So I will negate v1 minus A. Sorry, B. I'm sorry. Let me go back. B is v1. B is moving towards the west. So I will negate v1 minus B is v2. V2. I'm sorry. Minus velocity of A. What is the velocity of A? Is v1. The minus here is already in the formula, but it's moving towards the west, so I will negate it again. v1. Do you see that? And the negative gives us plus. So this one, we end up getting v2 plus negative v2 plus v1. And that gives us our VBA. That is what we have done here nicely. That is what I have done nicely over here for you. So take note of these ones and write them somewhere. Meditate on them because we are going to use them strongly to solve examples. I want us to look at the last case. The case where we have this. They are parallel vectors, but one is moving towards the north and one is moving towards the south. As we know, conventionally, if the bodies are moving towards the north, we assign positive, south negative, right? So for example, if I want to find VBA, as usual, VB minus VA. Now I don't want to write plus minus, okay? So check, B is towards the south, so conventionally it's going to be negative V2. Minus A is towards the north, so it's going to be 1. The minus is already in this formula. So that is what we get, and that is what we have done here. All right. Now I hope on this note, I want us to end here for the parallel vectors. When we meet next time, I'm going to explain the meaning of solving these ones with values and how you are going to interpret them when you have numbers with problems of this nature. Thank you, and don't forget to subscribe. See you next time. Bye bye.